A very good morning, everyone. In our previous video about current electricity, we ended the video with two major questions. Am I right? So, one question was, even though the electrons is what is flowing in a conductor, wherein the protons do not move, still we take the current direction as positive to negative, even though electrons go from negative to positive. And my question was, why do we have this disparity? Am I right? This is one. And the next one was, we know what is current. What is current? Rate of flow of charges. So when these charges flow, technically in this concept, the electrons go from one point to another point, they produce current. So what makes these charges to flow was the other question, right? So can I take a piece of wire? Let's imagine this is the conductor. Can I blow from this and expecting the electrons to go to that side? Or imagine I hold the wire like this. Can I expect the electrons to go down because of gravity? Or can I pour some water into it and that will push the electron flush out the other side? No, right? All these are not possible. They don't make the electrons flow. So how do you make the electrons flow? And that is your next topic. And these two questions are related. So if you have found the answer good, I'm happy about it. We'll get into the concept of how do you make the electrons flow. Okay, so to this we have certain analogies. For example, first analogy is, imagine you have a hot cup of coffee, very hot, and an ice cold cup of coke. You have both and leave both in the room temperature, let's say for 6 hours. So what happens after 6 hours? The hot cup of coffee will become cold and the cold cup of coke will become warm. With reference, this seems like warm. With this reference, even it's cold. But technically, what's happening? They both are finally coming to the room temperature. So what happens to the hot cup of coffee? The heat energy from the coffee will go to the room. And what happens to this coke? The heat energy from the surrounding will go into the coke. So what is deciding the direction here? The heat energy is going from higher source to a lower source. We can tell that the heat energy is going from higher temperature to a lower temperature, right? So if in the beginning only, or let's say after 6 hours, will there be any change of temperature between the coffee and the coke and the atmosphere? No, right? Because they all reach the same temperature. So what analogy can we get it from there? If everything is in the same temperature, there is no flow. Only when there is a temperature difference, there is a flow, right? Keep this in mind. Next. So let's say you're taking shower. When you take shower, you turn on the faucet and the water is falling. We don't have any sort of motor from the tank above your head to the faucet. Am I right? It's coming down because of gravity. You turn on the faucet and the water is going to go down to your head and you take bath. Why is the water coming down even though you don't have any sort of motor? It's because of gravity. Am I right? There is a potential difference when compared to your height. The water is at a higher place so that when that water is let to go freely, it comes to your height freely because of change in potential. Am I right? Make it even more simpler. Take up a very flat surface, pour some water on it, let it rest for like half an hour. After resting for half an hour, ensure the whole room is insulated, there is no sort of air movement. Without any sort of external force interference, will the water move from one point to another point? No, right? It will not move. Only when you hold the pan and lift it from one side, it will let the water move to the other side. What are you doing here basically? You're creating a potential difference. So the same term can be used as well in electricity also. That is potential difference. When you create a potential difference, that will make things flow. So here also you have to change the potential difference in terms of charges. That would make the charges to go from one point to another point. What were the analogies? First analogy was with respect to temperature and the second analogy was with respect to water, right? So keep this in mind because we'll be coming back to this analogy once we learn about the definitions. Now we'll go to the concept of potential difference. Only when there is a difference in the potential, there will be a flow of charges. So how can you create a potential difference in terms of charges? Can you heat it? No, right? Or can you hold the wire higher and lower, expect the electrons to go, or so we can't do it. So how can you create a potential difference in terms of charges to be used in a circuit? Think and tell me. We all know it. We all have done it in various forms of science experiments. Think and tell me. The one source of potential difference which you can use here would be a cell. It would be a cell slash a battery. Many cells together will constitute a battery. So as of now, we'll make it very simple. I'm talking about one cell. Clear? This cell will act as a source of potential difference. How? Let's construct a very basic cell. Let's say this is your positive side and this is your negative side. We all know it. Whenever you insert into a TV remote or a toy remotes or the car or whatever it is, we know which is the negative side, which is the positive side. So this is called as anode and this is called as cathode. We will not be getting into the chemical concepts of the battery because we have done it in your 8th grade and we'll be doing it in the future as well. Right now we'll focus on the physical aspects of the battery. So talking about the negative side, that is called as your cathode. For this to remember, you can remember the word panic. What do you mean by that? Positive anode, negative cathode. Okay, this is in terms of cathode, anode, electrodes. But if it terms in terms of ions, it will be anion is negative, cation is positive. It will be opposite. So don't confuse cation, anion with anode, cathode. Clear? What all you'll remember? We'll remember the word as panic. Positive anode and negative cathode. Clear? Now, as I told earlier, I'll take a piece of wire and I'll zoom into the piece of wire in certain region. Let's say this is the region I'm zooming into. So we have all these positive charges and around that we have these negative electrons which are directionless. Basically they just vibrate along any direction they want. This is a segment I'm zoomed in. The same wire that goes from this end to the other end and the circuit is completely closed. I'm not considering using a cell, I'm not considering using a key. I'm just making it very simple just to see about the flow of electrons. Clear? So what happens in this negative side? What happens in the negative side? What happens to these electrons in the wire in the negative side? Will it attract or will it repel? These electrons will what? Repel. Because these electrons and these anions are what charge? They are negative charge. Since they both are negative charge, these electrons will repel. Rather, the first electron which is in contact with your first part of the battery from the wire will have a repulsive force which will push the electron away from the battery. Clear? And what did we learn in the previous class? The value of Q is equal to N into E, wherein if you take 1 coulomb, we require how many electrons? We require 6.25 into 10 to the power 18. It's a very huge number. So the whole wire is made up of billions and billions of electrons, right? So this electron in this corner will repel the other electron, and that electron will repel the next electron, and that electron will repel the next electron. Like this, it continuously keeps on repelling one after the other, and the repulsive force will reach this part of the conductor which I am zoomed in. So on this part also, the electrons which were randomly vibrating in any direction they wanted starts to align themselves in one specific direction of repulsion. Clear? They repel each other, and finally this electron also is repelled, this electron also is repelled, and this electron also is repelled, and finally the one electron which is near the negative positive terminal also is repelled and pushed into the positive terminal. It is being repelled from this side and pushed into the positive terminal. Why? Because this positive terminal contains cations, and cations are positive charge, electrons are negative charge. So here we'll have what? Here we'll have attraction. So basically the electrons which are being repelled on this side are being attracted on this side. So when one electron is being pushed here, there's one electron being attracted here. So there is no necessity that this one electron has to go all the way to the conductor and reach here to produce current. That is not required. When you push one electron, that electron pushes the next electron, Like this, all the electrons are being pushed simultaneously, making it look like a flow of charges. Clear? And this flow, what you're creating, is what you call as current. I hope you guys understand now how current works. So basically, we have a battery which has positive anode, negative cathode. In the negative cathode, the electrons near in that wire are being repelled. That electron will repel the next electron. All the electrons in the wires are being repelled by each other. And finally, on the opposite side, the electron is being attracted. So this creates a flow of electrons. And what are electrons? Charges. And this flow of charge is what you call it as currents. I hope it is clear now. So technically speaking, since compare with which one? Water, and compare with your heat, it always go from high potential to low potential. Am I right? So technically speaking, this should have been your high potential and this should have been your low potential, but that is wrong. Whenever you mark the direction of current, the direction of current is taken from positive to negative, and the direction of electrons is taken from negative to positive, and this is what we also call it as electronic current, and this is what we call it as conventional current. Why do we have this difference here? Even though you know that electrons only flow and this is what is producing current, why do we learn the current direction as positive to negative? Like in electrons going in this direction but the current is in this direction. Whenever you mark current in any diagram you take up from magnetic effects of electric current or your current chapter also, any diagram you see from your NCERT, the current direction is given from positive to negative. Even though we know that the positive charges are tightly held. Can the positive protons move? We saw in the last class. They cannot move. They're tightly held in their locations. Even though we know that the positive charges cannot move, why do we take the current direction as positive to negative? Why? It is because of a blunder of a scientist. You all would have learned about this crazy scientist in your 8th grade who flew a kite during thunderstorm to check whether the same phenomena of electricity is happening behind your lightning also. Fortunately, he didn't die, but he contributed a lot towards your charges. And the scientist's name is Benjamin Franklin. So when this person invented, invented is the wrong term because it's discovery. When this person discovered about charges, he was able to identify there are two types of charges, positive, negative. And how did we identify? We identify using the basic concept. Oppositively charged things were attracting, similarly charged things were repelling. So he termed one as positive, other one as negative. He didn't know what was what. He just called one as positive, another one as negative. Fine. And at that time, we didn't have powerful theories or devices to look into an atom and the way they behave. So according to him, he thought that positive charges move because he didn't have clarity on this concept that protons cannot move, only the electrons will move. At that time, the clarity was not there. So when he framed this theory about charges and flow of electricity and everything, he just assumed that positive charges move. So according to him, the positive charges are moving and that is what is producing the currents. So based on this theory, for the next 30 to 40 years, a lot of inventions and much more higher order theories were given and published and widely accepted. Because even though he logically made an error, mathematically everything will work out fine. Clear? So because of that, the people who identified this as an error later 30-40 years did not want to go back and change everything that was written. So since then onwards, when we identified that what he told was wrong, we started to learn as two types of current. One is conventional current given by Benjamin Franklin, and one is the actual current that we discovered, that is a flow of electrons. Clear? So if they ask you about the direction of current, instead of telling blankly that it goes from positive to negative, you can tell that opposite to the flow of electrons. It's like I'm going towards north. Instead of telling I'm going towards north, I can tell I'm going against south. Same logic. Because we know it is wrong, we know it doesn't happen, but still we choose to keep it that way. So at least telling we can tell it in a positive manner. That's the whole point. So instead of telling the current is from positive to negative, you can tell the current direction is taken as opposite to the flow of electrons, which is electronic current that goes from negative direction to positive direction. And this is the paradox behind conventional current and electronic current. So whichever numerical you solve or whichever concepts you have in magnetic effects of electric current with respect to Fleming's left hand rule or right hand thumb rule, you always take the current direction from positive to negative and name it as conventional current. That's it. So until now we saw potential difference, that is you need to create a difference in potential for the electrons to flow. One electron on the negative side will be repelled, everything will be repelled, on the other side will be attracted. This flow produces the current which is called as electronic current, and the normal current is from positive direction to negative direction. So this is the concept behind which one? Potential difference. Now we will see what is the definition for that. We will learn, memorize the definition and the formula and see how conceptually relevant the definition is with this theorem. Clear? So talking about the formula or the keywords for potential difference, please make a note of it. Potential difference is given as the work done in carrying a charge. What is it? Work done in carrying a charge from one point to another point. It is the work done in carrying a charge from one point to another point. It's more than enough. So in that case, if I take up a wire, I take up a charge here, I name it as Q. When I take this charge from this location 1 to location 2, will I do some work or not? Now this is related to 9th standards work kinetic energy theorem, or we can take general theorem of work displacement concepts. So whenever I take up a charge or any object, I displace it from one location to other location, I am doing work, right? For example, how is the water able to flow down towards me? Because of gravity. That is the immediate answer. But what is the indirect aspect towards this in terms of energy? Whatever work you do in carrying the water from the ground floor to, let's say, 10th floor is stored inside the water in the form of potential energy. So when you open it, comes down in the form of kinetic energy. Clear? So whatever work you do is only stored and then comes in the form of potential difference and energy in all these aspects. Similarly, to take this charge from this point 1 to point 2, it is not an easy task. It's a very hard task. And to do those tasks, we need to do a lot of work. Why would it be a hard task? Think and tell me. Why would it be a hard task? Why do we have to do the work? Because when you imagine the wire, you can't imagine only the electrons, right? What else do we have? We all have the positive charges as well. So generally speaking, if you have 10 electrons, you will have 10 protons. If you have 100 electrons, you'll have 100 protons. If you have 6.25 into the power of 18 electrons, you'll have the same number of protons. So when one electron is trying to go from one point to another point, it might be attracted by other proton, that is the nucleus, or it can be repelled by the other electron. So it is not a straight path. It will be attracted on one side, repelled on the other side, attracted on one side and repelled on the other side. So it takes a lot of work for you to push this electron from one point to the other point. That is the work we refer here. And what is the work done on? The work is done on carrying charge from one point to another point. And that is stored in the form of potential, and that will give you the potential difference. Clear? So the formula for potential difference is given as work done by charge. So if you go deeper, actually in your 12th grade we will be having the concepts of EMF, Kirchhoff's voltage law and current law, where we take the direction of voltage in terms of sign convention for voltage in terms of direction of current. Those are much more deeper. To understand those level, we need to understand the basics first. And according to the basics, what is potential difference? Work done in carrying a charge from one point to another point. That's it. And the potential difference is what? Work done by charge. And this potential difference is what we call it as voltage, and hence unit of potential difference also is given as V, which is volt, and unit of work done is joules, and unit of charges is coulomb. So we can take that 1 volt is equal to 1 joule by 1 coulomb as one of your definitions. Clear? So how do we explain 1 volt? When you do exactly 1 joule of work in carrying 1 coulomb of charge from one point to another point, the potential between these 2 points is called as potential difference is called as 1 volt. That is the concept. Okay, so potential difference formula is given as work done by charges, which is equal to 1 volt can be given as 1 joule by 1 coulomb. That is, if you do 1 joule of work in carrying 1 coulomb of charge, it's called as 1 volt. This is the concept of potential difference. Now, along with this, simultaneously, I want you guys to compare another concept called as electric potential, which is more of a mental concept which we use to explore the scientific nature of various quantities like electric potential, gravitational potential, where you compare the energy in terms of infinity and what you have in measurable aspect. This was for potential difference. What we have is for electric potential. We'll have the same formula with minute change, which would be work done in carrying a charge not from one point to another point, but from infinity to a point. The common reference point that we use here would be infinity. So whatever work you do in carrying a charge from infinity to a point is given as electric potential. Clear? Next point, how do we relate this with this? So let me assume I have an infinitely long wire and this point is infinity, and I take up a point here, name it as A, and take up a point there, name it as B. So whatever work I do in carrying a charge Q from this point to this point, that will be given as potential at A. Which point? From infinity to the point A, whatever work I do is called as potential at A, not potential difference. Similarly, whatever work I do in carrying the same charge from infinity to B would be called as potential at B. Clear? So if I'm talking about potential difference from one point to another point, that is from A to B, I just have to find the difference from where? A to B, which can be written as potential at B minus potential at A. That's it. So what are we finding here? Difference, right? That is why this also comes under which concept? Potential difference, which can also be written as work done by charges. Clear? So we have learned two concepts as of now. One is potential difference, which is from your 10th grade CBSE NCRT textbook, which you'll be getting numericals for. This is the other relationship where you can expect basic 1 markers. They'll give you potential at this point as 10 volt. Potential at that point B is 40 volts. So what is the potential difference? 40 minus 10 will be equal to 30. That's it. So at any point when you compare with infinity, whatever work you do is given as potential, and you find the difference is called as potential difference. Clear? Please make a note of it. We'll go to the next part. The next part, what we'll do, we will deal about numericals that you can expect from this part and with the devices. So before rubbing the board, we can take a note of it. So since this is called as voltage and the unit is volt, what could be the device you could be using to measure it? The device like ampere, we call it as ammeter. For speed, we call it as speedometer. Distance, called as odometer. Similarly, here we call it as voltmeter, and there we connect the ammeter in series, right? Here we connect it as parallel, and that for the ammeter the resistance was almost equal to 0. Here for the voltmeter the resistance would be almost equal to infinity, and these two terms, what they mean, we'll be seeing in the upcoming classes once you know about series and parallel connections. Clear? So this is all you need to know about potential difference and the concepts here. You'll be getting questions only from this part. Apart from that, we'll be doing right now maybe a couple of sums. In that couple of sums, one is a basic sum which you can expect for 1 marker, and the other one is a little advanced, which was asked in your current 2026 paper in terms of charges. Okay, so we'll see both questions and we'll wind up for the day. First question is This is sample question number 1 under voltage. First question what we have is, voltage is given as 12 volt and the number of charges you carry is 2 coulombs. How much work could be done? What is the formula? Voltage is equal to work done by charge. So 12 is equal to work done by 2. So work done is equals to 24 joules. That's it. Very simple. They'll give you two of these three terms and ask you to find the third one. It's very simple. It's not a big deal. We'll come to the next part. So how can they make it a little more harder? They can relate this concept with respect to which one? Current. How can they do that? What is the one common thing we have? Q, right? We can take it as Q is equals to W by V, wherein Q is equal to N into E, whereas Q is equal to I into T. Like this, they can relate charge with three different formulas. That is W by V, N into E, and I into T. Clear? Next, one question that I found interesting in the current 2026 paper was, they told one electron. How many electron? One electron went from point A to point B, and the voltage between those 2 points were 10 volts. They asked us to find what is the, it was 100 volts, and they asked us to find what was the work done. What formula will be using? The same formula, right? Which is V is equals to W by Q, where we have V, but do we have Q? Q will be in terms of charge, but what do we have here? We have electrons. Electron symbol is E, and the value, you know, what is the value of electron? 1.6 into 10 to the power minus 19 coulomb. How we relate electron to coulomb here? Because we have Q is equals to N into E. So how many charges are we carrying here? One charge, and charge of electron is given as 1.6 into 10 to the power minus 19 coulomb, which ultimately becomes your value for Q. That's it. And already we have the value for voltage. Using these both, you can find the value for work done. So if I want to find the work done, if I have to find the work done is equal to charge into voltage. And what is the charge? 1.6 into 10 to the power minus 19 coulomb into what is the voltage? 100 volt. 100 will be written as 10 to the power 2. 10 to the power 2 and minus 19 will cancel out. So you got 1.6 into 10 to the power minus 17 joules. This is the amount of energy spent in carrying one electron across a potential difference of how much volts? 100 volts. Clear? So these are only two types of questions you can expect from this concept. Maximum of 2 marks, 3 marks is very hard to find, but definitely 1 or 2 marks will be getting, and it will be from only what I've written on the board previously and what I have on the board right now. This is the only concept we'll be having. So we'll have a small recap. We saw today what is potential difference. What is potential difference? Potential difference is the work done in carrying a charge from one point to another point, and the unit is voltage. 1 volt is given as 1 joule by 1 coulomb. That's it. And talking about a source of potential difference, that will be your battery, and we saw two types of current. One is your actual current, which is electronic current that goes from negative to positive, and other one is your conventional current, which goes from positive to negative, which does not exist. It's a blunder made by Benjamin Franklin. That's it. Next, we have formula based questions. This is V is equal to W by Q. First was a basic question. Next was a little advanced, where in terms of charge, you got electrons, number of electrons. If they give you 2 number of electrons, you'll take 2 into E. If you take 5 electrons, you'll take 5 into E. Find what is Q, then find the answer. Same in terms of IT also. They give you current and time, find Q, then substitute Q is equal to W by V, and whatever they're asking, find the other thing. That's it. So this is what we have in terms of potential difference. Before I wind up the class, I want to give you a follow-up activity for the next class. Now, you would have done some activities or experiment with respect to your science exhibition or played with toys, right? So imagine this thought experiment. So let's say you have one small battery and you have a LED bulb. very small battery, like a watch battery. When you connect, will the LED go or not? It will glow, but it will be very faint. You can see a spark coming up and going. That's it. So remove this battery, remove this battery, small battery, and add a bigger battery. Let's say AA size battery, which you use for the remote. Now the bulb will glow, but a little more brighter, right? Now imagine you take this out. Imagine that big blue color wala battery, which has a positive and negative on the top itself, the one that becomes very hot when used for a longer period of time. That is very common when you do for a science fair. So use it and connect the bulb. What will happen? The bulb will glow even more brighter. Now take this bulb and directly put into the socket. What will happen? It's not a good idea, don't do it. But what will happen if you put in the socket directly? You will have 220 voltage in the house. The bulb will burst. So what observation can you make here? What observation can you make here? When you take up a bulb, kind of the smaller battery, what will happen? Higher battery, what will happen? And what is happening when you put into the sockets? Same thing my brother also did. That's when I actually first learned about what we'll be learning in the next class. What he did was, he was playing with a motor. He ordered some motors. He wanted to create an aviation motor. All his attempts were failed, and somewhere he saw that if you add more voltage, the power will increase. I'm not in the actual keyword, but the power will increase. That's what he thought. So he took the motor directly inserted into the socket. He was frustrated and directly into the socket, and the socket burst. And he was on the ground when we were in the other round. So when he came out, he was safe, it's fine, but the motor was burst. So think about all these analogies. What's happening when you increase the battery? What is happening to some other quantity? Why is it going brighter and all those things? And come back to it. In the next class, we'll be continuing with this follow-up and see one specific law. Clear? Thank you for your patience. Thank you for watching. Please practice more numericals based on current and voltage, basic sums from previous year question bank, or even you have a website called learncbse.com where you have the questions based on your chronological order of difficulty, where the first few questions will be only based on current and voltage. You can try these questions. All the best. Thank you.